Okay, so we're going to start exercise 14a, factorial notation. It's part of the combinatorics topic, which is exercise 14, chapter 14, sorry. Now, for the first exercise, we're just basically introducing the factorial notation and try to understand why we need to have such a notation here, what is the advantage of to have notation like this. So we're going to start the lesson. All right, so the first example I'd like to give to you guys is like, for example, if we have four letters, A, B, C, and D. Now the question asks you about how many different arrangements if the order is important. So if we rearrange all these four letters and to form a different word, right? And then how many different arrangements possible? Okay, so we can always start the arrangement with, like, for example, A, B, C, D. That's the first one. Then we can switch C and D around. Then we'll get A, B, D, C. All right, and then we can still keep the first letter A, but switching the second letter to be D, C, and then that's BD, and we'll continue the process. If we do that, just give me 1 second. Right, so that's DB, and then we can move on to AD, BC, and ADCB. All right, and then we can continue the process by having a B to be the first letters. All right, so BACD, BADC, okay, oops, BADC. And then, as you can see, we can continue the process. Then we can move on to C as the first letter, and then we can move on to D as the first letter. All right, so now if you look at this, all right, for each of these arrangements, if we start with the letter A, we've got 6 different arrangements here. Then we start with letter B, we should have another 6 of them. Same apply to C and D to begin to as a beginning letter here. So in total, we should have a total of 24 different arrangement. All right, one order is actually important. Okay, so A, B, C, D is different to A, C, D, B. They're all different words, all right, because order is important. So there are 24 different arrangements. All right, so obviously this method, is actually listing all the possible arrangements, and we just do some, we do the counting and we work out the answer. Not ideal, because if we have more letters like A, B, C, D, E, and F, and G, H, and it goes on, this entire process is enormous of working out, right? So we need to have a better way or better system to work out this answer here. All right, so for the first lesson here, I'm just going to introduce very briefly about this method, all right? I'll talk about more like in details in the next exercise, but this exercise is all about introducing a factorial notation. All right, so the easier way to do that is actually called a counting method using boxes, if you look at these. So if we have like 4 boxes, okay, each boxes we can put a letter in. So we've got A, B, C, D to put in. All right, then what we need to do is to think about this, right? If we have that's the first position for the letter. For the first place, we can have all 4 different choices. You can put A inside, or you can put B, or you can put C, or you can put D. There is no restriction here. So you can have 4 different possible choices. So 4 choices here. All right, you can choose A or B or C or D for the first box. Now for the second box, all right, if you have chosen a letter here, that means this letter is gone, and all right, you only have 3 choices left. So it doesn't matter which letter you choose at first. All right, you always have 3 letters remaining, all right, to choose from. So therefore, the second box you have 3 choices. Same apply to the next one. The second last box you have 2 choices, and the last one you only have 1 choice. All right, does make sense. All right, imagine if you have already chosen 3 letters here, so therefore you only have 1 letter remaining, so you don't really have a choice at the end. That's it, okay? So therefore, to do this question here, then we should be able to find out what is the total, okay? Total possible, arrangement. So therefore, the total possible arrangement, we actually multiply those possible choices together, so we actually multiply them together. As you can see, that is equal to 4 times by 3 times by 2 times by 1, which is 12 times by 2 times by 1, and that's equal to 24. Okay, and that is the same as the previous answer we have before. Okay, but much easier. All right, so 24. Now, so as you can see here, we have such a product, right? We have 4 times by 3 times by 2 times by 1. Now, such product with descending sequence, all right, of whole numbers occurring in the areas of mathematics, we call that, factorial. There is a notation for it, all right, and we call that factorial. So we can, instead of writing 4 times 3 times 2 times by 1, we can actually write the answer in terms of 4 factorial, and that's the notation here. Okay, or that's called 4 factorial. All right, so that notation tells you that, if we have n factorial, it tells that, you have n multiplied by the number that decreased by 1, which is n minus 1, and then you keep timesing it, decrease by 1 again, which is n minus 2, and you multiply n minus 3 until you times all the way to times by 3, times by 2, times by 1, and that's it. All right, and that's what the factorial notation is about. All right, so therefore, if you see a question like, if it's n 6 factorial, what does that mean? Well, that is 6 times by 5 times by 4 times by 3 times by 2 times by 1. Okay, you continue the process. If it's 5 factorial, it is equal to 5 times by 4 times by 3 times by 2 times by 1. And continue the process. 4 factorial is going to be 3 times by 4 times by 2 times by 1. As you can see, that's what the factorial notation is about. Okay, so I put this, 6 factorial, 5 factorial, 4 factorial as a purpose, and also I write it like this, okay, as a purpose. So hopefully you guys can see what's going on. There's something called unrolling factorials. What does that mean is you can actually change the 6 factorial to 5 factorial because as you can see here, that entire part is just equals to 5 factorial. So we can unroll the factorial once to get 6 factorial is actually equals to 6 multiplied by 5 factorial. So, so that means if we have a smaller number factorial, all we have to do is times by the number that's 1 above, all right, and then we'll get the, this n plus 1 factorial there, all right. Similarly, we can also write 6 factorial is equal to 6 times by 5 times by 4 factorial. And that way we're basically unrolling this factorial twice, okay? So this is the concept of that unrolling factorial. All right, to me, it's sort of like, you are expanding the factorials a bit, okay? So instead of writing 6 factorial, writing 6 times by 5 factorial, 6 times by 5 times by 4 factorial, and it goes on. The reason why we need to have those unrolling factorial, notation techniques is because eventually you're going to see questions where you're not allowed to, well, you can use a calculator to do it, all right? You can always use a calculator to find out the factorial notation. For most of the calculator, the factorial notation is above the one I have is here. There's a 1 key that's just below the on key here. So on your calculator, just 1 below the on key, that's the factorial notation. So all you have to do is just press the number, okay, and press that key. You should be able to see the factorial notation. Okay, and you can press equal to find out what's 5 factorial, okay, which is 120. So you can actually try this. But then the reason that you need to know how to do the unrolling factorial techniques, all right, is because sometimes you don't deal with just number factorials, you deal with an algebra factorials as well. So for example, if I ask you to simplify n plus 2 to the power, n plus 2 factorial over n minus 1 factorial. If that's the case, right, how do you simplify it? Your calculator is not going to help you that much. So what you need to do is you need to be able to unroll the factorial and to simplify further. So for example, this question here, n plus 2, all right, factorial, I can unroll this factorial to n minus 1 factorial. So what I can do is I can keep timesing it, the term 1 less than the previous one. So I times by 1, n plus 1, and then you times by n, because that's 1 less than n plus 1, and then you times by n minus 1 factorial, okay? And you stop at that point because you want n minus 1 factorial. The reason for that is you can cancel both the top and the bottom, like this, and hence you actually simplify it into n plus 2, n plus 1, and times by n. Okay, and that will be the simplification of, this expression here. So you need to be able to unroll the factorial properly. Okay, all right, let's move on to another, slightly harder examples here. How do you simplify n factorial over n minus r factorial. Okay, all right, so how do we do that? Well, again, the idea is very similar to the previous one. We need to unroll the factorial. So we need to unroll the top one, so therefore we can get the bottom, okay? And then we can cancel that, the terms out. So we need to unroll the factorial. We're going to start with this. N factorial is equal to n times n minus 1 times n minus 2. And continue, but then what we really want is at the end, we want n minus r factorial here, okay? All right, so therefore, we need to have the term that's before it, which is n minus r plus 1, okay? And then if you really want to do it, you can also write down the term that's before that, which is n minus r plus 2, okay? And then the denominator is equal to n minus r factorial, so that way we can cancel out the 2 factorials here, and you end up with n times by n minus 1, n minus 2 times by dot 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 until you have the last term, which is n minus r plus 1. All right, so in total we should have like r factors, okay, r number of factors. Okay, all right, so that's sort of like an idea why we need to be able to do the unrolling factorials. Another example of that is you need to be able to do the questions where the question asks you to sort of doing like, the calculation question, like in plussing, addition, and subtraction type of question. All right, so that's why you also need to do it. Okay, so let's have a look at that. All right, so in example 2, we can have a questions where it's like, 1 over n factorial plus 1 over n plus 1 factorial. So how do we plus these two together, right, to get the final answer? All right, so again, if you think about it, treating this as like a fraction. If you treat this as like a fraction, it's all basically, making the same denominator. All right, if you're adding 2 fractions together. All right, so how do we add the 2 denominator together? Well, how do we making the denominator equal to each other? Well, firstly, n factorial and n minus plus 1 factorial, they are very similar. Okay, they're almost identical. They only differ by a term. All right, so therefore you need to use the method by making the same factor, denominator. So usually what you do is you make the larger one as the denominator, the common denominator. So you keep the n plus 1 factorial first. So all right, and this one you change that into n plus 1 as well. So how do we change from n factorial to n plus 1 factorial? Well, if you multiply by n plus 1, you get n plus 1 factorial. So it's like, if you have a 6 factorial, but you want to change it to 7 factorial, all you have to do is multiply by 7. All right, if you don't understand this, all right, think about 6 factorial is 6 times by 5, 4, 3, 2, and 1. All right, and if you multiply an extra 7 in the front, that gives you 7 factorial. So that's the idea. All right, so therefore all you have to do now is if I times here by n plus 1 times the numerator by n plus 1, you should be able to get it, right? All right, so now you get n plus 1 as the numerator. Okay, that becomes 1 here. So now, it's easy. You're just adding the 2 fractions together. So that should be very easy for you to do. So that becomes n plus 2 over n plus 1 factorial. All right, so that's how you add it together. Okay, all right, so this is the type of question you are going to get. All right, the next thing that we need to understand is a bit of like a definition. So all we need to understand here is like, and this is about a factorial unrolling factorials, right? So if I give you another example, like for example, if we have a 6 factorial is equal to 6 times by 5 factorial, and then 5 factorial is equal to 5 times by 4 factorial, and then continue the process. 4 times by 3 factorial, 3 factorial is equal to 3 times by 2 factorial, and then 2 factorial is equal to 2 times by 1 factorial. Now for all of those, we can actually do the calculation using our calculator. I remember 5 factorial is 120, so that becomes 720, okay? And that is just equal to 2 times, this one here is just equal to 2 times by 1, so that is 2, all right, and that's 6. That should be, 4 factorial should be 100, so 4 times by 3 times by 2, that should be 24. Okay, all right, so that's easy to calculate. What's 1 factorial? Well, 1 factorial is just equals to 1 times by 0 factorial. Okay, now the interesting part here is we do know 1 factorial is just 1 times by, like, basically 1 times by, like, 1 itself, right? It's just equals to 1. So therefore, the definition really tells you that, if you having these two, making them equal to each other, 1 times by 0 factorial is equal to 1, so therefore 0 factorial is equal to 1. So we need to try to understand what definition is 0 factorial is defined to be 1, okay? Reason for that is, as you can see, the empty product is regarded as being 1, because if nothing has yet been multiplied, then the register remains as at 1, okay? This is the idea. All right. Okay, so that's good. All right, now let's move on to try a few questions from the textbook. All right. So the first couple of questions will be just like, evaluation question. Okay, so like finding the answers without using a calculator. All right, so let's just try this example 3. All right, I'm just going to pick the question from the exercise. That's question 2G. Okay, 2G. The question asks you to use the notational factorial and the unrolling factorial method to actually calculate what is the value here without using a calculator. So do not use a calculator. All right, so in order for us to calculate this, all right, I definitely need to unroll this 12 factorial. So 12 factorial can be done into 12 times by 11 times by 10 times by 9 factorial. All right, and the denominator is just 3 factorial times by 9 factorial. And then you can cancel the 9 factorial with the 9 factorial here. So you should be able to get like 12 times by 11 times by 10. Now 3 factorial is just equals 3 times by 2 times by 1. Now from here, you can cancel the 12 and the 3, which is give you 4. And then 4 and 2 becomes a 2 at the end. So therefore, it's pretty much, that's it, okay? You can do the question without even using a calculator. That becomes 22 times by 10, which is 220. All right, so that's how you do the question without using a calculator. Yeah, I'll show you another example. Let's see. Okay, question 2H. 8 factorial divided by 4 factorial times by 4 factorial. Oh, by the way, 4 factorial times by 4 factorial, don't assume that's equal to 16 factorial. It doesn't work like this way here. All right, it's not 8 factorial either. Okay, so don't just do it like that. Okay, so there's no such thing like this. Okay, so we do 8 factorial is just 8 times by 7 times by 6 times by 5 times by 4 factorial. So that way we can actually cancel one of the 4 factorial there. All right, and then we can simplify the expression. 4 factorial is just equals to 4 times by 3 times by 2 times by 1. All right, so to simplify that, we get 2, this also 2, and that cancels out. So at the end, we should have like just, 2 times by 7 times by 5 as the numerator. There's nothing on the denominator, so that becomes 70. Okay, so you can, check your, you can also always check with the calculator using the factorial notation key. All right, to check for that. Okay, all right, so next. The next type of question is some sort of like simplification question, okay? Like, for example, question 6. Question 6, maybe question 6E. We'll start with that one. Like, they ask us to take out a common factor. So that's a really interesting one. 9 factorial, 8 factorial, and 7 factorial, they're adding together, and the question asks you to factorize, simplify, okay, by taking out the common factor. All right, so firstly, you need to understand that from 9 factorial, 8 factorial, and 7 factorial, they all have some common factors here. 9 factorial is just equal to 9 times by 8 times by 7 factorial. However, 8 factorial is just 8 times by 7 factorial, and 7 factorial is just 7 factorial itself, right? So the common factor clearly is the 7 factorial. So that is the common factor here, which means if you want to simplify this, you can just take out a 7 factorial out, and for the first term, that's just 9 times by 8. For the second term, it's just 8, and for the last term, it's just 1. And the outside is still 7 factorial. That's 72 plus 8 plus 1. So at the end, it just equals to 7 factorial times by 81. All right, that's how you simplify it without using a calculator, of course. If you have a calculator, you don't really need to simplify. You can just do it without any problem. All right, question F. n plus 1 plus n factorial plus n minus 1 factorial. All right, so how do we simplify this one here? Okay, we need to take the common factors. Again, we usually just take the common factor with a lower term. So this is bigger than this, and n factorial is bigger than n minus 1 factorial. All right, so we can take n minus 1 factorial out. All right, and then remember n plus 1 factorial is equal to n plus 1 times by n minus 1 factorial. So if we take n minus 1 factorial out, we have n plus 1 times by n left, plus, now n factorial is just equals to n times by n minus 1 factorial. So therefore we just need to plus n and plus 1 to finish off that. Alright, so we can now simplify what's inside the bracket. Alright, so therefore we should be able to simplify this to get n squared plus 2n plus 1, alright, which is a perfect square formula. So n plus 1 squared and minus 1 factorial, and that's how you simplify that. Okay, all right. Remember this entire exercise, the first exercise, is only introducing the notations. We don't really talk about the arrangement that in details. I only talk about the first example as an arrangement question, but it's about using the notation. It's about to it's about to learn how to use the notation properly, how to do sort of like algebra calculations in terms of that notation state. Right, I'm just going to do one more as an example 5. Alright, so the question is a proof question. So prove that it's one of the questions in the exercise as well. Prove that k over k plus 1 factorial is equal to 1 over k factorial minus 1 over k plus 1 factorial. Okay, so that's a proof question. So what we're going to do here is going to start from the obviously start from the side where you've got more terms there. Okay. All right. So we'll start from there. All right. So it's very similar to the previous question we did. All right. We need to combine the two fractions together. As you can see, we've got we need to make the common denominator. It looks like the common denominator this time is k plus 1 factorial, just because we need to have the larger terms or the larger numbers to be the common denominator. So therefore, in order for us to change from k factorial to k plus 1 factorial, remember we times by k plus 1. So we need to have k plus 1 on top. That is just equal to 1 again. Alright, so therefore that gives us k plus 1 minus 1 over k plus 1 factorial. Now to simplify this, we get k over k plus 1 factorial. Alright, which is the left hand side. So that's it. That is how you are supposed to do the questions. Again, as I said, it's a very simple exercise. Alright, try to understand how to deal with the factorial notation. And then in the next exercise, we're going to talk about more in details about the counting order selections. Okay, thank you.